Hey Opties! Today we're looking at slope-intercept form of a line. And we're also going to discuss parallel slopes and perpendicular slopes and use that knowledge for slope-intercept form of a line. So slope-intercept form. You can use this form for any line. The thing that makes this useful is it's really good to use for graphing because of that y-intercept is a really easy point to graph on your line. And then if you know your slope, which is easy to find by looking at this formula, you can just apply the rise over run when you're graphing. The slope formula is written here. We have also seen this in the point slope video. Rise over run, which is the change in y over change in x. So subtract your y's, divide by subtracting your x's. In your formula, m is always the coefficient of x, which means it's the number that's being multiplied by x. And if it's written in slope-intercept form, it's always the number in front of x. The y-intercept is b. It's always that number hanging out at the end of the equation in slope-intercept form. It is always the y value for where x is 0. Now here's the reasoning for that. A y-intercept means that's the point where your line crosses the x-axis or your function. It could be any type of function. It still has a y-intercept unless it just simply does not cross the y-axis. But why does x have to be 0? Okay, think about your axes. X is 0 right here where I'm crossing this y-axis. That's on the x-axis. 0 for x is right here. So the question is, well, the y values that would line up with that x value of 0 are the whole entire y-axis. So your y-intercept, that number has to be on the y-axis. So if you're trying to find where you cross the y-axis, you simply look for whatever the y value is for where x is 0. Let's take a look at this image. It shows us the change in y and the change in x, and these dotted lines and the segment formed by these 2 points show a right triangle. So if you want to think about the change in y as like the height of the right triangle, the change in x is like the width of the right triangle. And it has this point 0, b. B is that y-intercept, and it occurs where that x value is 0. Now let's take a look at parallel and perpendicular slopes. Remember, a slope is a tilt of a line. So if you're going to be parallel to each other, there's some sort of distance between you, because otherwise you're going to be the same line, right? You're going to be right on top of each other. And if you're parallel, you're never going to touch. So you have to be slanted the same amount if you're not going to touch. Otherwise, if you're slanted a different amount, you're going to eventually intersect. Parallel lines have to have the same tilt, so they have to have the same slope because tilt of a line is a slope. So parallel lines always have equal slopes. Let's take a look at this image that calculates the slope for 2 parallel lines on this graph. We can see that the lines are not touching, and it doesn't look like they're ever going to touch. So they're parallel, and the slope of the first line, or the top line, is 4 divided by 4, which is 1. And the slope of the second line is -3 divided by -3, which is also 1. So even though the change in y and the change in x were different, once you calculated the slopes were the same. Let's talk about perpendicular slopes. Remember, perpendicular means when you intersect each other, when 2 lines intersect, they form a right angle, or many right angles in this case. There will be 4 right angles. This one, this one, this one, and this one. So we can see on our graph that we've got this little box in the corner, and that shows us that these 2 lines are perpendicular to each other. So let's think about the slopes. The slopes of perpendicular lines are always 2 things going together. They're always opposites of each other, and they are reciprocals of each other. Opposite means you're going to change sign. So if you're positive, you become negative. If you're negative, you become positive. Reciprocal That means you're swapping the location of numerator and denominator. So if it's a over b and you're finding the reciprocal, it's now b over a. Let's look at these slopes. The first slope is a positive 6 divided by a positive 4, which is 3/2, or 3 divided by 2. The second slope is a negative 2 divided by a positive 3, which is negative 2/3. So let's make sure that these are opposite reciprocals of one another. If we look at this first slope, 3/2, it's positive. Let's make it negative to accomplish the opposite characteristic. So now it's negative 3/2. If we want to make it a reciprocal, we flip the fraction. So we are changing the location of numerator and denominator. We're swapping them. It's still negative. Now the 2's on top and the 3's on bottom. Well, we started with 3/2 and we got to negative 2/3. What happens if we start with negative 2/3? It becomes positive, so it's a positive 2/3. Then you flip it and becomes a 3/2, which is the other slope. So they are opposite reciprocals, and it goes either way. They're opposite reciprocals of each other. Let's take a look at the steps to solve if we want to write an equation of a line in slope-intercept form that is parallel or perpendicular to a given line through a given point. Step 1. In case you have to write the opposite reciprocal of a slope, I suggest your first step be make your slope a fraction. So if it looks like our fraction already, it already has a numerator and denominator, then don't do anything differently. If it's, say, a negative 3 like we have here, go ahead and put a 1 as the denominator, because if you do need to do the reciprocal, then you will have your denominator there in order to know, okay, well, this now becomes the numerator. Otherwise, you might be like, oh, how do I make this a reciprocal? So make it a fraction first. We also have this given point here just to help us finish the steps to solve, but you don't have to do anything with that yet. Step 2 is to determine your new slope. So if the problem asks you for a line that's parallel, you want to keep the same slope, so you don't have to change the slope at all. If it asks you for a perpendicular line, you want to make the opposite reciprocal of that slope. So our slope of the original line was negative 3. Making it opposite, it becomes a positive 3. And making it a reciprocal, that positive 3 over 1 now becomes a 1 divided by 3, so a 1/3. So that's how we got our perpendicular slope here. Step 3, substitute your point and your new slope into the point slope formula. Because think about it, you've got a point and a slope. You might as well use the point slope formula. It's just the easiest way to get at least some sort of equation that's for that line, and then you can rewrite it in slope-intercept form. So we've done that. We've substituted our given point and we've substituted our slope, and we just picked that it was going to be parallel just to show this example. Your last step, once you've got your point slope formula, you want to rewrite that as slope-intercept. This is how you do that. You want to get your y by itself, so in this case we would add 4 to both sides. And you want to get your parentheses to go away. So distribute your slope. Now, the next step after doing both of those will give you 2 constant terms most of the time, unless you have a 0 in there with your y or something. So you want to make this to be 1 constant term to find your y-intercept, your b. So just combine those like terms. And then our final answer was y equals negative 3x minus 2. So you've gone from finding your new slope, putting the point and the new slope into point slope form, and then rewriting as slope-intercept form. So there are 4 steps, but really it just boils down to 3 things. That first step again, writing your slope as a fraction if needed. Now let's do some practice. Number 1, what is the equation of the line in slope-intercept form that is parallel to the line y equals negative 5x minus 3 through the point negative 5, 7? Okay, so let's see if we're going to need to write our slope of the original line as a fraction. We're going to be parallel parallel to that line. So we won't have to find an opposite reciprocal. So we really don't need to do step 1. Step 2 is to figure out what your new slope is. Well, if we're parallel, we're keeping that slope. So our new slope is -5. So that's going to be m. We have our point and our slope. Let's substitute into the point slope formula. So y minus the y value, which is 7, equals the slope, which is -5, times the quantity of x minus the x value. So we're subtracting a -5, that becomes a +5. Now let's add 7 to both sides. So y is -5 times the quantity of x plus 5 minus 7. Now we want to get rid of our parentheses. We'll do that by distributing our slope of -5. You don't have to draw those lines, but it helps some people, so do it if it helps. -5 times x is -5x. -5 times +5 is -25. And we've got our -7 hanging out. As you can see, we've got one last step. We want to combine these two constant terms, and then we'll be done. Y equals -5x minus 18. And that's it. It's parallel to the given line. We can tell it has the same slope, and it's through that point. Number 2, this is going to be a perpendicular one, so slightly different. Still an equation in slope-intercept form. So since it's perpendicular, we are going to find the opposite reciprocal slope. Our original slope is already a fraction, so we don't need to do step 1. So 1/5, let's make it opposite. So it's positive, it now becomes negative. So a -1/5. So we've done the opposite section. Just make a note of it there. And now we're going to do reciprocal. It stays negative. The 5 is the new numerator. The 1 is the new denominator. And 5 divided by 1 is just 5. So it stays as a -5. And that was reciprocal. We've got our new slope. We have our point. Let's go to point slope formula. Y minus the y value. This one's easy because x and y are the same point, or the same number. So we don't have any danger of mixing those up. So it's also an x minus 4, just like the y minus 4. And we'll add 4 to both sides. So at this point, we're solving for slope-intercept form. Y is -5 times the quantity of x minus 4 plus 4 on the end. Distribute your slope of -5. -5x plus 20 plus 4. Last step, combine those two constant terms. Y is -5x plus 24.